Hi everybody and welcome back to the Renewables podcast, and we are joined again by my co-host Mark, and we're having a really interesting conversation and kind of a bit of a hot topic in the industry at the minute. So what is it that we're going to chat about, Mark, and how are you doing?
I'm doing all right, thanks. We're doing well in the day job, which is the main thing, keep the lights on and the wheels of industry turning. But this is an interesting one because, like you say, there's been a lot of conversation around it, and I don't think we've actually got a full-on solution as yet in terms of products that are available. We can get into that through the chat, and it's to do with switchgear and consumer units.
It is, and even more specifically, this whole argument around, can we run a solar and battery system from a customer's pre-installed consumer unit? Or if we're changing a consumer unit, do we need to look at other things as part of the installation of solar and battery? Do we need to fit a separate consumer unit because of the current ratings of it? And so we're going to try and get into the weeds of all of that as much as we can within the time that we've got. We always struggle with the time, don't we? We could probably chat and speak about this sort of stuff for hours, but yeah, I mean, you might expect us to have a prop from Proteus, and we do, don't we, Matt? We're gonna chat about the Proteus DB, mainly because we've got it here and it relates to what we're talking about, because there's elements of this DB that are going to be very relevant to our conversation on current ratings and things that we need some more help with, really, as industry, to work out how do we actually solve this problem of fitting everything into one nice, neat distribution board like this new one from Proteus.
Yeah, I mean, you're dead right. Typically, in the past, you'd be looking at these 16 amp inverters being tied in with a consumer unit, and the prospect of anyone getting near the 100 amps consumption was pretty low, wasn't it? And that's kind of the thing we're working within. It is that 100 amp element as a whole, and I think the manufacturers of switchgear are kind of catching up to that. And to be fair to Proteus, they're listening to the installer base and they're making some of those tweaks. And we can see there in that board with the twin terminals on the main switch. That's something that they've brought in from a different range to try and cover off the burnt out tails points of termination that we find so regularly with inside consumer units. You've got your SPD that mounts straight onto the buzz bar, so that's another spare way that we've saved in the board as a passive device as well. And the fly leads are already on that, pre-loaded into the board. There's even the pointless spirit level in the top there that I don't think some of the marketing team at Proteus were that keen on having in the range, but certain elements of the design process required it. And we all see that when you go to look at it in whatever brand you fit in. I don't think I've ever used one of those to assume something is straight and level. So yeah, it's one of those things that I think a lot of manufacturers could actually ditch. There's the cable entries as well coming in through the back, which is a nice solution. I know Sam loves his Instagram worthy boards, so we've got low down range of holes there and the higher up larger knockouts as well. But my understanding is, despite all those fantastic innovations, it's still rated at 100 amps as an enclosure, which is the thing we're trying to cover off as installers with typically hybrid battery storage and in solar PV systems, isn't it?
Yeah, and to really nail what the problem is that we're looking at today is that we've got these distribution boards that have been out there, since the dawn of time, or since the dawn of time since I've been alive. It's always been 100 amps, single phase boards. You didn't really give it much thought because it's just what they're being made like, and you kind of think, right, well, maximum 100 amp fuse on that incoming single phase supply, 100 amp board, that's all fine. The issue now we've got is that we're introducing a second supply to that site, and therefore we've got potential to draw 100 amps if we've got 100 amp main fuse from the grid, because we've got 100 amps that can go through that fuse, and arguably more with the slow blow of those fuses. And then we've also got maybe a 16, 32 amp, 40 amp, 50 amp supply coming from all these hybrid solar and battery systems, or two inverters, a battery inverter and a solar inverter, or multiples of that as these systems getting expanded. So what we want to try and have a chat about is really where we see this going, what the problems are with that, and how we would love, as just two installers having a chat, industry, manufacturers, regulators to help us get around this problem so that we don't have to fit loads of different boards in an understairs cupboard where we maybe haven't got or a kitchen unit where we haven't actually got the space.
I mean, that's exactly it in a nutshell, isn't it? I mean, if you're lucky enough to be installing a gateway, a lot of this can kind of be covered off because the gateway does the heavy lifting in terms of your inverters being connected, and your heat pumps even can be wired straight into some of them, and your EV chargers. But most customers typically end up with a hybrid inverter or a PV and AC coupled battery storage inverter direct to the consumer unit. And you pretty much summed it up perfectly there, Sam, because you could have all of that going off where you've got an electric shower that's in use, an electric vehicle that's on charge, a heat pump that's running. You could have a high base load of consumption in a customer's home, and then all of a sudden you've got a big array out in the garden. And we've installed some pretty big systems as relative newbies to industry already, with high powered inverters contributing again to that. And you can't go putting that into a 100 amp regular consumer unit. Should say that there are single phase options already for 125 amp rated boards. They're type A boards that you would typically use in a commercial environment, but they're not really that common, and they are quite large and bulky, and it doesn't really help solve that issue. And it was interesting, just speaking off camera, you'd mentioned that you'd kind of found out that bus bar is 125 amp rated in that. So I think the manufacturers are starting to explore what this 100 amp enclosed rating actually involves, and making those adjustments, because we do need it. The solution at the minute is, like you said, a separate board for your EV and for your PV, maybe to take them outside of that. But then you've got more points of connection with Henley blocks that you've got to fit into a cupboard. There's other issues around failure and maintenance of them. And it's avoidable if we can get a little bit of innovation in the manufacturing space.
Yeah, absolutely. I think I think there's a lot of chat around what the problem is with these 100 amp boards. And I've seen a lot of chat, and I might be missing something massively glaring, but a lot of the chat is around, well, the main switch is only rated at 100 amps. For me, I'm like, that's fine, because we can only bring in 100 amps. It's the enclosure, the bus bar, the rating of that assembly only being rated at 100 amps, when we might have, drastically, I think these should be rated 200 amps. What that means in a manufacturing process, I don't know. But for me, I think the only way to really kind of close this off is to give this a big, dirty 200 amp stamp, or have it as like a Renewables ready board. Because even at 125 amps, which is great that bus bar is rated at that, it doesn't necessarily mean that enclosure is 125 amps. And to be honest, 25 amps headroom is not that much nowadays, especially when we also look at potentially not too far down the track, bi-directional EV charging and discharging. It's another thing that's going to be another source of contact. So let's imagine a scenario. You've got a customer where they've just had a new DB installed, probably a lovely new Proteus board like this, being installed. There's a feed-in tariff registered solar PV system. There's also a new battery system that they've had, which, the PV system is probably a 3.68 kilowatt inverter, so 16 amps. We've then got a 5 kilowatt battery storage system, AC coupled, so got another inverter there. So we're already up at, 36 amps. And then we've potentially got, in whatever form it ends up taking, a bi-directional EV charger, which we don't know exactly how fast they're going to discharge. Let's say worst case scenario, we've got 32 amps coming roughly back into that. So it's like 60, I can't remember where I was, 68 amps, something like that, coming back into that property, potentially coming back into that property. So 25 amps, whilst that's great, is better than most, but is not, for me, is not an end point. That's kind of using something else that, like a rating, probably come from a commercial board for it. And I've seen a lot of chat about, 16 amps, it could probably handle 16 amps. There aren't many out there now that are just handling 16 amps.
No.
So it needs to be a really robust solution that actually allows more than 100 amps to flow around that board. For me, even Henley blocks, they're 100 amp rated. So
yeah,
it's
a good point. We're looking at a 125 amp figure, and maybe that's a bit short-sighted, knowing what is coming. And you could see it where people maybe would have additional AC coupled battery storage as well. I think you're right about the 100 amp main switch, because you're unlikely to get a DNO that's going to be very happy with you starting pumping 100 amps out to the grid, even during demand side response events. They're not going to want that, are they? I think whatever time we get to in the future. So it's not really a case of the component being put at risk of seeing it. It is more around this enclosure rating, and maybe it is to do with the heat build-up and all the testing that they've done of compatibility with their RCBOs, for example. If it is going to be consistently running 125 amps by nature, it's going to be warmer in there, isn't it? And maybe there's other factors that they need to do further testing on. And it might be that existing ranges comply already. They just don't know that because they've not been tested, much like Proteus's bidirectional RCBOs that they didn't really know was a thing until it became a thing. So it's one of those where we might see that lots of what is available is fine. It's just never been tested and approved for that.
Yeah, definitely. And you raise a good point and about, the DNO aren't going to be happy with you exporting 100 amps through that board, so you're not going to get more than 100 amps flowing through that main switch as far as I can see. But they've got a solution to that, which is this whole G100 export restriction. They've already got that control.
Yeah.
And so one argument within this, which doesn't really help, well, there's two. The first argument that doesn't really help, which is the really static guidance, which has come from the IT, has been about lowering the ampage supply to that consumer unit so that it takes account for the generation that is coming from it. So if you've got 100 amp supply and you've got 32 amps of potential generation that are also going to supply that board, then their guidance, which I'm sure I got this right, is that you downrate the supply into that distribution board to, say, 60 amps, so that then the 60 amps plus the 32 amp supply from your generation together don't go above the 100 amps.
Yeah.
But that DB has probably got electric shower, electric hob, air source heat pump, or it's not a viable option for me. It's just going to blow. It's just going to blow.
You're factoring in a failure point there, aren't you, at some stage? That's a hard design to achieve. I know there's variations on calculating maximum demand, and we can play around with those figures, but we know how those things play out in time. If you stick enough 60 amp fuses in enough people's homes, eventually you'll get a few of those doomsday circumstances occurring. I do wonder if it's one of those things where we're maybe worrying about something that is unlikely to ever be an issue. Because if you think about it, if you've got that high base load of consumption that, say, is 100 amps coming from the grid, and you've got a massive solar system that's producing 50 amps, the chances are that the customer's going to struggle to draw all of that 125 amps as consumption in enough places. I think it's going to be very, very rare circumstances where you might have a customer that's got maybe a sauna, a couple of EVs, and they're deliberately trying to consume a lot of power. I'm thinking of the kennels job that we did, where I know they do have quite a lot of consumption, and the intention there is to make full use of that as much as they can. But I think in most cases it's probably unlikely really to ever... I'm just trying to think of a circumstance for other jobs, a typical solar system, for example. So it's one of those where it's maybe case by case, and where technically you could fall foul of that actual rating. The prospect of it ever going beyond that is probably tiny percentages.
Yeah, I mean, it goes back to this whole thing around, like we've mentioned on numerous podcasts, like the PAS side of things. Is there much evidence that batteries are catching fire or batteries are causing fires to get worse? And it's kind of like, there maybe isn't. I don't know. I've not got the numbers, but it's trying to be preventative rather than reactive, which the regs or industry gets accused of a lot of waiting for something bad to happen to then react. And, maybe that's part of this, and them looking forward at, right, okay, well, we've got two supplies here. We need to be careful on the ratings of this of these enclosures. But the other option that I was going to mention was that there are some manufacturers out there that allow like monitoring CT clamps. So you've got your main ones, certainly for battery storage systems, doesn't necessarily help too much on solar only, but it could be incorporated, is that monitoring CT clamps could be there purely to look at the current flowing around that distribution board. So for example, on this board here, let's say this was one of 3 boards in a property, and this had all the household load on it, and we had our solar battery. Feels wrong touching it, even though I know it's dead. Solar and battery circuits in there, and have a monitoring CT clamp on the main incoming supply. This system knows how much the solar's generating and knows how much the battery is either importing or exporting. So it can do the simple maths of going, well, okay, that's fine. And I know how much I'm importing because I've got a monitoring CT clamp on there. So if we say, right, don't let this enclosure go over 100 amps, it can potentially clip the power back or limit the battery's discharge or charge, depending on, which way the issue is as it's approaching 100 amps, to react to that. And for me, that's actually the only way you can possibly do that, because it means you can still keep the 100 amp incoming supply, or we are seeing more of them being downrated to 80 amps now, but they're probably hitting 100 amps for, I think they say like 4 hours or something, or 2 hours, something like that. Yeah. So you still got the potential there to get 100 amps in. Because we've got to remember that when the battery's empty and it's dark, you aren't going to be adding anything from these generations. It's not like another grid supply where you could draw on it any time. So it's got to be factored in that it's based on the time of year, the weather, and and what you've got connected in here. So for me, it has to be some sort of dynamic solution to it.
Yeah, I think that's a great shout. If you look at the way that EV chargers were made to behave to satisfy the service fuses and protect them, even subboards where you go and install them in a garage and the customer doesn't want to pay for that cable to be upgraded, you can still install one and use that demand limitation to stop it ever causing you a problem. And with all that technology, for a lot of the equipment, you can look at heat pumps as well. They're probably capable of looking at what's going on in terms of import and export and adjusting their behaviours to try and keep within a certain amount. And maybe that's a good way of approaching it, rather than just saying, okay, we want a 200 amp rated board and we're just going to bung everything in it. Maybe it's a smarter way to manage a consumer's demand anyway. It's good encouragement for them. I don't know. It's a tricky one, because we're working off where we are now with solar panels at typically 450 watts. Who knows, in like 10 years there may be 1,000 watt panels, and you've got all this extra input coming from solar energy, and your battery banks could be way bigger because there's been innovation on all of that as well. And maybe the manufacturers of switchgear need to get a little bit ahead of that, looking at the speed that those things have changed in the last decade. And we might realistically start seeing that big transfer of energy. That could be what consumers want. So they park their EV up that they've taken to some supercharging station somewhere and paid 5p a unit for, and they've brought it home, and they want to take half of that energy out in an hour and put it into their battery storage in their home. And the journey for that to happen is through a consumer unit, and there's going to be quite large currents because of it. Maybe you're right in the way that it's been looked at. That 125 amp figure is maybe a bit short-sighted if we're looking to solve that rather than limit it from occurring.
Yeah, definitely. I think we have to find out from companies like Proteus and others how is it possible to get this to 200 amps? If they go, this needs to be double the size for the heat dissipation, needs to have some aluminium cooling fins on the back, it needs to have all this other stuff, or a fan, then it maybe starts to rule that out. And then we have to look at more dynamic solutions to it. And it might even end up being a mixture of both, because we've got to remember that we don't go down the road of these being rated enough to basically do what you like with, 200 amps, like it's the figure I've kind of banded around, then there has to be rules applied in different areas to force people to fit the CT clamps if they're fitting it into a board, or if any part of that network to that board is going to be only rated at 100 amps and it isn't fused down. Because there's some properties that are on 60 amp fuses, or that are on these smaller systems, and they might go, well, I'm only fitting a small solar PV system. The nature of this installation means that I'm not going to ever go over the 100 amp rating. So there will be installations out there with generation that is absolutely fine. But like we've mentioned, when load, when exporting from cars comes in back to the grid, or even just back to the home, this is its route. This DB is its route into that property and back to the grid. So if you've got some 100 amp Henley blocks, then there's potential there for it to be receiving 32 amps, and then because that's that's been connected in after the main service fuse for that board to draw that 132 amps into it. So then you're looking at, right, well, do I need like a little bus bar chamber and all this? And then you're trying to do all of this stuff underneath a kitchen unit, and it's just, and then you get into the whole outdoor DB situation because there's nowhere else for it to go, and it's a bit of a mess. So for me, let's go back to ground zero and go, how do we make this board 200 amps? And if they go, we've had a look, and it needs to be twice the size, or it needs to have some really expensive, cooling fins or fans or something. If it is heat related, then that might be a case where we go, right, well, we need a better, more intelligent solution, because we already have it for export limitation with the G100, don't we?
Yeah, we do. I think there's a conversation in there with Pete and Ian from Proteus to get themselves down and come and visit us and explain it, because I'm sure there is a reason why that is 100 amps in what it is, the way it's tested or the way it's constructed. And as you said, it's probably ventilation and cooling that's the primary driver of all of that. But we don't know as electricians. We're just guessing based on what we assume, and they will know. So it sounds like a good podcast episode in and of itself.
That's an open invite then.
We'll just suggest it to Pete, and I'm sure if we offer him a nice sandwich, he'll come along and have a chat with us. But it's an interesting one for us as installers, because it's okay, we can assume, I've just said that a couple of minutes ago, we can assume that the customer is very unlikely to ever be drawing over 100 amps through that consumer unit, whatever's going on in terms of generation and the service fuse rating. But it's not impossible. And as designers, we need to kind of factor that in. And that customer might not live there for longer than a couple of years. Some other family could move in and the utilisation could change. And you can't design for every possible eventuality. But I think setting up for something that could occur is a good place to kind of start from. And the gateway aspect does solve a lot of these problems with the bigger systems, because most of them do usually incorporate a gateway. But there's a lot of manufacturers now that are innovating away from that. We saw from Ancasolics when they came in to speak with us that they're looking at methods that don't involve a gateway. And I'm sure that other brands will copy that process or innovate in a different way themselves, because it's an extra component for them to manufacture and ship and all the rest of it. And if technology exists where you don't need one, that'll be where we get to, won't it?
Yeah, and I think a really important part of this is that normally when you're increasing the load of a consumer unit like this, you've got an electrician here that has come and put that electric shower in or converted the hob to electric where it used to just be gas. So they are kind of every step of that, they are taking responsibility for that rating, make sure that rating isn't exceeded. And you see loads. I've been to properties where they've got two electric showers at like 45 amps each, and then they've got a electric cooker and all that. And you're looking at it thinking, oh my lord, that must be on fire when all that stuff's on. And the difficulty with the renewable side is that actually when we've installed this equipment, for there to be a fundamental change on how that piece of equipment is used, we don't have to return to site. It's an update onto the system. Suddenly that battery can now export to the grid. So suddenly it's not just charging up with little bits of power during the day from the solar. It's now pumping 5 kilowatts into that board for 3 hours, or it's withdrawing and charging with 5 kilowatts or more of energy overnight or during a low tariff period during the day. And I think that's going to become more common when more flexible tariffs come on the market and more people switch on to how do we make more money with these battery storage systems fitted. And all of that is a case that we don't have to return to site for all that to happen. So when we've made our initial assessment to go, oh, well, they're only going to be dribbling a little bit of power into this as the sun's shining and they're not in at home, suddenly the day after, Octopus release a new tariff that means that the more they can buy in at a certain time, the more they can pump back, they're earning more money, then that makes a huge change. And who knows, we might end up seeing that with EV chargers where, it's been marketed by EV companies where just change out your 7 kilowatt charger to this bi-directional one and it'll automatically work. And maybe people then don't take into account the impact that has on the distribution board when we're pumping that power back into the property, into the consumer unit as well. So suddenly a lot of stuff can change quite quickly after our initial design, where really we haven't actually gone back to site to now that that system has got more capability, we've not been back to site to actually reassess if the infrastructure can handle that new capability, because we don't know about it.
No, there's a couple of great points you've made in there, and I never even thought about that in terms of the tariff side of things, because it's all well and good we can look at it from kind of a design point of view based on what the customer's lifestyle's like and what they're using. But they could be making that financial decision when there's a very generous agile tariff that they're on for export and import, and they might decide we're being paid 10 pence a unit just to use energy right now because it's really windy. I'm going to put the hob on even though I'm not cooking. I'm going to put the oven on. I'm going to leave the electric shower running. I'm going to go mad and pop both the EVs on charge, and I'm going to start charging my AC coupled battery system up. And it's sunny outside as well, and their solar system pumping another, 10 kilowatts in if they're lucky enough to have a 10 kilowatt inverter. And all of a sudden, they're way above that 125 amp rating by no other reason than they want to make some cash out of it. So there's those kind of decisions that could be made that no one had designed that in. It's not something you think would happen, but they've been driven to it to make some money. I'm not going to pretend I haven't had those thoughts with some of the agile pricing that's popped up now and then. I think, there's lots of customers will make those decisions to try and increase that return on investment. And then, again, just about the whole way that houses are kind of joined together with electric vehicles, there's going to be different approaches in that. Somewhere they'll go DC, straight from the car to the battery stack. Sage Energy already look like that's the approach they're taking. There's other ones, I think is Indra, which is doing the conversion from the DC into the AC. So there's no real defined method that's been used for that. So I think it's one of those we'll just have to wait and see. And I guess that's the difficulty for manufacturers like Proteus. It's all right us sitting here saying we want a 200 amp board. Maybe they are looking at it thinking we just don't know quite what's going to happen with this. And if we make it, we're then sat with a very expensive product in our range that we can't sell. So
I think you are right, but hopefully this conversation can help start some of that in our small way. But equally, if Proteus or whoever else, all these other brands said we can get you to 160 or we can get you to 180, if we get you to 200, it is just going to be like a monster. You have to
like
fit.
a tank.
It might be that there has to be a slightly more standoff. It might stand off a little bit more from the wall. And there has to be some more ventilation at the back or whatever, I don't know, but there might be some changes that could be made to make that in its footprint work at 150 amps, 140 amps, whatever. And then that then offers us as installers the ability to go, 140 amps is better than 100 amps, so I'm going to go for that, and then have to assess what I do. But that's why I think when we're in a world of trying to kind of think our way out of these problems through software, why are we not doing that with this? We're looking at the G100 side of things. There's not a mechanical disconnection there. If it went like a separate little contactor that's watching the current, it's all based on the software within that battery storage system to export limit that has been that has got that G100 stamp of approval. So why not do G101 and do it for for monitoring of the current flowing around the board? It probably wouldn't be a G standard, would it? Because it's it's domestic, or like it's within the actual customer's installation. But something to solve this problem without us having to destroy someone's house to fit a massive board. Because like you mentioned right at the start, it might be that a lot of these DBs could handle 150 amps without much of a problem. But equally, if they can't, does that mean that if we've only got space for 1 dB, we have to change that full dB just to fit the solar PV when the customer maybe doesn't have the budget for it, there's maybe not the space for it? And so actually adding another circuit with a clamp to set up the kind of maximum current this board can see means that more people can get renewables because they're not having to change the full dB that might have only been installed a few years ago, because all these ones we're fitting now are 100 amps. So if you fit one tomorrow and then next week this there's something released where actually you should be fitting 180 amp, it means that literally that install you did yesterday should have a new dB if they wanted something like a renewable energy system fitting. So I think it has to be some sort of software thing.
Yeah, where we are now, I think that's the only workable solution we've got as we are today, and we're kind of relying on that, and then we're in the world of does that satisfy regs or not. But I think the fact we've had that with EV chargers, and the DNOs have been quite happy with that as well, or as happy as they ever are. I think there's a promising sign there that that's a workable solution. I guess it's just making us aware as installers, because I'll be honest, it's not something I really considered. I think it was till we sat down with Michael and Graham on a podcast. I think they mentioned it either in the discussion or off camera. It all becomes a bit of a blur, some of these chats we've had.
I think it was in the discussion from memory.
With those guys. But yeah, and it is something that we do need to be factoring in. I think there's maybe an issue around the fault current side of it as well, because I know sometimes with the DNOs, and I explored this after we'd spoken with Ben when we'd said about if you've got an export limit in place and you're using a G100 limiting device, why are the DNOs really that bothered if you start adding additional inverters? And actually a DNO friend of mine said that it's to do with the fault current that could be found in the grid side of things because of the extra generators, the kind of, I guess it's the voodoo world of electrical and how that all behaves. And maybe that's an element of it as well, that when you've got all these different sources of coming into the board, as you've said, you could have AC coupled batteries, you could have your PV, the grid side. Maybe it's to do with that, because I know we already assume that as a whole can withstand way more fault current than the breakers are rated for as a whole assembly, as a bit of a way of getting around some of the fault currents you'll find in central London, for example, where you might be quite close to your transformer and you could be seeing, I don't know, 10k or whatever, but you've still got 6k rated breakers and that's fine. Maybe there'll be some sort of statement around that, okay, we know that it's not really rated to that, but you can still use it, because that's kind of where we are now with a domestic grade consumer unit.
Yeah, it is. I mean, it's one of those topics that starts to unravel. When you do really go into it, and that doesn't mean it shouldn't be tackled, though. That's the problem, isn't it? Because ultimately, there's hundreds of these installs probably going on every single day, and the longer we don't tackle this, the more of those installs potentially, it's not going to be every install that is going to face a problem with it, but that 1 in 100 that does have an air source heat pump, 2 EVs, electric shower, they've gone all electric like we've been pushed to do, and suddenly we're finding actually the distribution equipment isn't suitable for that level of current. So it does need tackling, but we need some great minds on the case, don't we?
I think it's the same when you just mentioned about heat pumps. It's got me thinking about RCDs, because there's been a lot of chat with heat pump installers. I saw a post from Damon actually where he was mentioning it not that long ago around Type B RCBOs that some manufacturers want, and other ones, I think there's Type F that they're stipulating, and the kind of learning journey that they're going on with that, because that's kind of outside their wheelhouse as heating engineers, but it's something that they're having to start to consider, because is that an available device for the board that's installed that they're asking the electrician to connect into when they're going around doing their proposals? Because a lot of them will work with electricians, but they're not taking them around to survey every job. That's just the nature of the beast. And again, for us as installers of EV charge points, some now where they want Type B protection, and others where it's Type A, and we've got investigations that are ongoing, as I've just learned from Electric Safety First, about the suitability of Type AC RCBOs, and if there really was ever that big a deal about them. They're doing some of their own research and testing beyond what manufacturers have told us, which is quite interesting. So it's like so much for us to try and get to grips with the switchgear. And I got found out, I'm happy to admit, I installed a SIG Energy inverter into an existing client install of ours with a Give Energy gateway. So those of you who don't know, they come with a 30 milliamp RCD built in, and upon turning that on to run it, the RCD was tripping, and I was convinced I'd done something wrong, but it wasn't. It's that inverter needs 100 milliamp RCD protection, and I thought we were long since past those times, that most inverters now were quite happy on 30 milliamps. That was just an assumption I'd made. It's my fault because I hadn't read the data sheet, but it's one of those where you can get caught out sometimes, because then you're in that position. If I've installed that SIG install where I've used twin and earth cable, for example, it's gone through the fabric of the building, I'm now looking at 100 milliamp RCD that doesn't satisfy the regs just because I didn't read a data sheet. Yeah,
I know. It feels like at times it's easier to get it wrong than it is to get it right, because there's contradictory information out there, and there's obviously what products want and what the regs want, and it is very tricky. And I think you've got to try and just relate what you're going to do to that specific job, rather than trying to take everything in. And you've got to take what the regs say as very seriously, but also you've got to use your own engineering judgment on that particular job, haven't you? Really, as an electrician or a plumbing and heating engineer, to actually go, well, what is right for this job, and can I satisfy all those elements of the regs that I need to satisfy, doing it this way or that way? And I think we're good as tradespeople at kind of thinking around problems, because we're natural problem solvers, because customers come to us with a problem, and we tend to solve it as tradespeople. So it's trying to think around that. But there are times where there's just a critical mass of problems that need to be really thoroughly thought out by people that look at that specific issue and go, this is the way forward. And I think that's what needs to happen now with the consumer unit, so that we can kind of go, right, there's all these problems, but this is now the way forward. We either operate these, we monitor these, we do all this these other voodoo stuff that we haven't thought about to get around this problem. And I don't think lowering the supply into that board, just to take into account the solar generation, battery discharge, potentially the future discharge of a car into that. Do you have to lower that supply again when you've got the potential of discharging an EV into the board? It doesn't feel like a viable solution. But yeah, certainly the RCD side of things, it reminds me when I was employed, when I was very early on in my career, and suddenly I can't remember what inverter it was, but I'd gone through the manual and the data sheet, because I was a bit nerdy like that as an apprentice. I'd look, and I found that this inverter needed a 100 milliamp Type A RCD, and you could not find one of them. It was like Depoke or something like that. Yeah, one of those ones. And the company was not happy with me, because they were about £150 each back then. But that was to satisfy it, and that then led me back into the RCD thing that you've just mentioned, Mark. Is that some of these inverters have like RCMs or RCDs built in, so residual current monitors or residual current devices like an RCD. But then that gets us into that world of that doesn't actually comply with regs, does it? Because it's not a BS, device. It's just an electronic device.
Yeah, it's back in the whole EV angle again, isn't it, with a different product. And it is an issue for us as installers. And I'd seen Will from the Talked Up podcast was talking about this either on his Navitas stuff or on his actual show around inverters out there that need RCD protection, and this whole bi-directional thing might not be that big a deal, because lots of them are on MCBs. And there is that argument that generally you'd be supplying them either on the surface through trunking, or you're with steel wire armor cable, and the requirement for RCD protection maybe isn't there in terms of the switchgear. But a lot of older inverters do have those requirements for RCD protection in the manufacturer's instructions. And even ones that are installed today, they're stating that they need it. So it is, for me, definitely a thing. And whilst the majority of properties are kind of PME, TNCS, there's those rural installs that are TT anyway, and by nature, they're going to need that RCD protection, whatever's going on with the inverter instructions or your cable installation type, just because it is TT. So I think it's one of those where we need to really keep our eyes on the ball and don't do what I did and just assume that you don't need an inverter, an RCD, or that you need a 30 milliamp and it'll be just fine. And read the data sheets like Geeky Sam did when he was an apprentice. And make
I still did. I wish I still did as much as I used to do.
Make sure you get that information. And it's the same with the heat pumps as well. It's a journey for you guys and girls doing those things. And it's a world I've not explored. We've not been involved with heat pumps whatsoever. And there's the cost implication of that in terms of the overcurrent protected device itself. And Proteus have got those single module Type B RCBOs that go in there as boards, but other manufacturers don't. And if you've got the space in there to fit a double module Type B, are you going to have to put it somewhere in circuit and end up with outdoor consumer units that we see so often around heat pumps and all the issues with that? It's one that I think we need some proper, clear guidance on from maybe the IET, as you've just said, maybe the PAS documents, and hopefully in our small little way with our Renewables podcast, we can raise some of that discussion among those of you watching along. Maybe it'll spill out in social media and there'll be a few discussions as well. I think alongside the 125 amp rating, there's a lot of stuff we need to take into account with switchgear around all of this stuff. And it's probably, I'm going to say, in at least 60-70% of cases been done wrong at the minute. And that's something, before we get to the mass uptake, as I've mentioned a few times in other discussions, that we've really got to get a handle on now before this is absolutely everywhere and we've got issues in existing, as you said, existing consumer units that somebody's connected something in without really thinking or considering it, as I wouldn't have done maybe a year ago. And then you end up with that problem millions of times over, and the statistical thing that happens, you end up with an issue, and then we're reacting to it rather than preventing it.
Yeah, absolutely. It does feel like we're in the lab at the minute. This is all being tested out there. These regs and the PAS document. It's almost like it's been a lab test and something's gone wrong in the lab, and so we've had to release tell the scientists to alter what they're doing and all that. But like you say, as soon as that's out in the wild, where most properties are getting this sort of stuff installed, which I do think will happen certainly with battery storage. I think it will. And we've got an interesting conversation coming up with Jamie, hopefully, around the grid, and so are more people going to be getting battery storage because the grid gets more, a bit more unpredictable and not as secure as we're maybe used to it being in most areas. And so then people are getting this sort of equipment installed not because of the renewable part of it, they're getting it installed because of the backup side of it, because they prefer that than a big dirty diesel generator outside. But it still has all of the potential that a renewables battery would have in terms of feeding back into a board, the RCD protection. And you raise a great point there around the TT earthing side of things. Potentially that might mean that certain batteries won't be able to be installed within that type of installation because, by its nature, we're having to fit 30 milliamp RCDs on the final circuits to that. So it's like, well, actually, okay, well, sorry, we've just spent a week fitting you this battery, but we've actually now realised that we can't actually get it installed because of this, this issue that it's having. And is that okay to be a equipment problem? Do we need to reassess the milliamp rating on that RCD for that type of install, where it's not necessarily a user-facing install, it's more of a distribution to a battery, or it just all gets a little bit mucky, a little bit murky in that area. So, yeah, let's see where it goes on all of that. Again, we don't have the answers. Hopefully you've not tuned in for the answers, because we don't have them, but we want to have that conversation to start trying to raise this topic up the agenda a little bit, because, like you say, we are in that really early stage.
Yeah, I think you've seen the government announcement that we discussed, which probably when you're watching this maybe a month ago. There's a lot of funding that they're sat on, and just waiting to put the meat on the bones of how they're going to apply that. But we're talking billions, which is looking at being directed towards domestic PV and battery storage. Quite how it's going to end up looking, who knows? But that could be the real fire that gets things lit under the industry to really propagate this into everybody's home. I think we're waiting to enter those times. So as installers, it's probably going to end up being quite good for us, as long as that's carefully managed and you get the best value for taxpayers out of it. But we'll see a lot of this rolled out, and we want to get the switchgear around it done proper, basically. We want that as installers. I think most installers do. We don't go to work to do a bad job. I'd like to think that lots of people watching us talk now are the same mindset. And we need a bit of help from the manufacturers to really consider that and get on top of it, both in terms of the inverter manufacturers, the heat pump manufacturers, and also those from the world of switchgear, and then those writing the regulations around it, because we just can't figure that out to a workable level other than ending up with the software looking after the maximum current that's flowing to the board, as you've just said, Sam, earlier on in this chat. We need a bit of help, don't we, really?
We do. AI has got all the keys. We'll see.
Chat GPT.
Yeah, we'll chat GPT it, see if they can work it out. But yeah, it is a bit of a headache. And since I think from that podcast, I think it was like one of our first podcasts, and we bagged the IET, which is fantastic, which was a great discussion. And since that podcast, every time we fit and do an install, I'm thinking about this now, and I'm like, oh God, we really need to get something sorted with this, because a lot of tradespeople take a lot of pride in the work, and they don't want to be caught out with something like this. But equally, we need to know what to do and how to how to address it so that we're not getting calls back because they've turned their oven on and it's blown that 40 amp fuse we've got to put into the board to, because now and again their battery and their solar and everything might be discharging into that board. We need a comprehensive solution that has been thoroughly thought out, and I'm hoping those conversations are happening. And if not, then this is kind of a drive for those to start, because we do need help as installers to fix that kind of, or answer that question.
Yeah, and we'll maybe play our little small part in trying to get Pete, Ian and Kieran from Proteus to come and have a chat with us, or one or all of them, to set out some of the angles that they can think of, because maybe it's not something that's top of their agenda at the minute, and us asking them might prompt them to think about it, and get some answers for no other reason than we want to know.
Yeah, exactly. And I think if it's only going to take one manufacturer to solve it until all the other ones go, oh, okay,
yeah,
this is a thing. So it takes one manufacturer to sort of stick their head above the parapet and go, yeah, we've sorted it. And then you can see how popular that brand would be, because then all the rest of them are like, oh God, we've got to try and get something sorted. How have they done it? And you have that kind of that early stage where it's kind of the only option potentially. Doesn't solve existing installs where people have got brand new Proteus board or whatever board it is that's 100 amp and they're wanting solar and battery being fitted into it, but it maybe starts that, it sort of resets the clock and go, right, okay, from now on these ones are getting fitted, these are 200 amp or 180 amp, whatever it is that we can get out of them. Or it's a software fix, and we keep coming back to that, or it's AI.
Yeah, software, AI, or voodoo.
Not a bit floaty answers there, aren't they? But I think that's really the only way I can, in my small way, think of a way around it. Really. Yeah.
I think we've given that a good run through across all areas. Unless there's anything else you want to add on to that one.
No, I think we have done it. I think it's not just up to us to raise this now. I think it's up to a lot of people that are listening or watching this as well. Just start asking those questions, and because just two guys asking the question is not as powerful as hundreds or thousands of people starting to ask that question and going, yeah, what do we actually do with this? And it's not a conversation that we've started. I've seen it out there, but it's just the initial embers. We want to try and really get that fire going with this topic, because it needs sorting now, like you've said before. It's everywhere, and then suddenly we've got a lot of work to do to try and fix it when the fire's already burning.
Yeah, absolutely. I think you've pretty much summed it up perfectly there. So I'll take us out, shall I?
Yeah, absolutely.
Yeah. So if you have watched this, Pete or Kieran or Ian, we want you down to come and explain yourselves in short. Wherever you're watching and listening to this, please don't forget to subscribe to the channel, leave comments, give us a rating as well if you're watching on Apple or Spotify. We're really keen to try and build that up to show the people what we're trying to do here with the show. If you've got any topics you want us to cover that are like this one or on consumer units and switchgear, also fire that in. We're here to have those conversations that are helpful to those of you watching along as consumers or installers. Otherwise, I've loved talking to Sam as always, and we'll see you on the next one.
Thank you.